What if we could predict failure? Automotive crash tests using dummies were some of the first simulations devised to improve safety. If we look back, we see how the digital revolution changed everything. In the age of the digital twin, now millions of miles of driving are simulated in the production of autonomous vehicles. They are fully immersive sensory learning environments, from machine learning to video games to smartphones, smart homes, smart cities. This robot is an excavator that has autonomy and collision avoidance. The digital twin is the core environment by which we're able to program and train a robot to execute a behavior. You can design, build, test, deploy, and operate very complex systems in interactive and immersive ways in our digital twin. It is as perfect a facsimile of the real world as we can make. It will be very easy to pinpoint and track objects, but we need to collect real-world information first and correlate it. We start by creating a digital representation of our environment. Hand draws every element. We can scan the environment using technology like photogrammetry, using a drone-mounted camera. Or we can use LiDAR, which produces an incredibly accurate representation of the environment, and depending on the type of LiDAR, can keep our digital twin up to date in real time, constantly scanning for changes in the environment. It's one thing that Uni does very well with its simulation technology. Through that innovation, we are able then to allow a robot to see a virtual world in exactly the same way as it would see a physical world. Now that we've built, we can place our robot in that environment and start to program it to operate in the manner that we want. We have to build an identification system for this robot to traverse this digital environment. So we show it a trail to follow. We want our heavy equipment to follow the path of a lead vehicle driven by a person. Therefore, we'll use a high precision to follow. We can generate the path using any one of several methods, like a digital twin in conjunction with real-time 3D technology, or a human operator can manually generate the path for a robot to follow. Now our robot knows where it is in our digital representation of the world and where it's supposed to go. Now it has to get there safely and avoid running into obstacles and structures. It has to see the world it's operating in and learning, where the robot learns the right behaviors through trial and error, operating in our digital twin, just like we learned from crash test dummies of old, but virtually and much faster. The robot now sees the digital world through a virtual sensor that behaves. It will fail a lot, millions and millions of times. But with each failure, it learns what works and what doesn't. Over many attempts, it ultimately learns how to complete the task we've set out for it. So that is the knowledge of the physical world. Sensors to experience the real world, and machine learning algorithms to process all that information. You can use it such as improve transport logistics, increase safety, reduce environmental impacts, conduct inspections and field maintenance on energy sites, improve airport security and resource planning. We're now